Assalamualaikum and hi. My name is FIRDAUS bin RADZI. My metric number is 207337. Today, I will going to present introduction of frame, trusses and machine. So let's start with frame. Okay, frame is known as the engineering structure of various shape, such as curve or straight, in which at least one of the member is a multi-force member. A member acts upon by three or more forces. These forces are generally not directed at the member on which they act. The use of the frame is to resist the moment that have formed during the loading process. Two types of frame. Rigid structural frame. The structure in which beam and column are constructed monolithically can be described as rigid frame structures and function collectively to resist the moment produced by the applied load. Pin-ended is frame structure can be constructed rapidly and considered to be non-rigid if its support conditions are removed. Fixed-ended is type of rigid frame system and conditions are usually fixed. Braced structural frame. Bracing between beam and column is normally provided in this frame system to increase their resistance against lateral force and sideways forces due to the load applied. Gable frame have the peak at their top and used where there are possibilities of heavy rain and snow. Portal frame usually look like a door and very much in use for construction of industrial and commercial building. Advantages of frame structure is their ease in construction. It is very easy to teach the labor at the construction site. Frame structures can be constructed rapidly and economy is also very important factor in the design of building system. Frame structure have an economical design. Okay, next, trusses. Trusses are simply defined as triangulation of member to make the stabilized structure. Trusses are designed to support load, are usually stationary, fully constrained structures. Trusses consist of two force members only, where the members are structured such that the assembly as a whole function as a single object. Trusses are most commonly used in bridge, roof, and tower. Trusses are constructed of triangular unit designed with straight member. The end of this member are connected at joint, known as node. They are able to carry huge load, transferring them to supporting structures such as load-bearing beam, walls, or the ground. Trusses are typically made up of three basic elements. The top chord, which is usually in compression, a bottom chord, which is usually in tension, bracing between the top and bottom chord. Okay, next, machine. Machine is an assembly of interconnected components arranged to transmit or modify force in order to perform useful work. Whether they are simple tools or include complicated mechanisms, their main purpose is to transmit input forces into output forces. Machine, like frame, always contain at least one multi-force member. All machines consist of component or part and unit. Each component is a spare part. Each component is a separate part of the system and may have to be separately designed and assembled. In turn, a component may be a complete part or consist of several small parts that are joined together by riveting and welding. Several machine parts are assembled to form what we call as complete machine. Example of machine. Let it utilize mechanical energy to cut the metal. Turbine produce mechanical energy. Compressor use mechanical energy to compress the air. Engine consume the fuel and produce mechanical energy. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Iman bin Ahmad, matrix number 205901. I will be explaining the trust structure that we are going to analyze. So this is the structure that we choose. This is a structure of a bridge. So the first one is to draw the free body diagram. So usually a bridge will be supported with a pin at point A and a roller at point O. So this bridge is a 14-meter long, and every triangle is 2 meter wide and 3 meters high. Now we assume that the external force that going to exert on the bridge. So this is a bridge. Basically, a car will move on it. So we put on a 2,000 Newton on point I and 15,000 Newton on point E, because usually weight of a car is about 150, 1,000, 1.5 to 2,000 ton, 2 ton, 1.5 ton until 2 ton. So 1.5 times gravity, we got 15,000 Newton. And the at point A, it was supported with a pin. We have two component of force that going to act on point A, that is AY and AX. And because O is supported with a roller, there will be only Y direction of force. So now we're going to find AX, AY, and also OY. Fx equal to 0, because there is no x direction of force, so Fx equal to 0, therefore Ax equal to 0. Fy equal to 0, we got negative 15,000 minus 2,000 minus 20,000 plus Ay equal to 0. Ay plus Ay plus Oy equal to 35,000 Newton. If we want to find this, we use moment, sum of moment. So we use at point A equals to 0. So 50,000 times 4 meter, 20,000 times 8 meter, and O minus Oy times 14 meter equals to 0. So we got Oy 15,700, 15,714.285 Newton. AY, we got 19,285.7.15 Newton. Okay, this is the force that is acting, the external force that is acting on the bridge, on the structure. Now we are going to calculate the internal force or the truss using joint method. We're going to divide every point into each smaller component of internal force. So this, based on the free body diagram, the triangle is isosceles. That means the triangle have two same length on the side. So we can find the angle. Alpha equals to 75 and beta equals to 36 degree. And joint E, Fy equals to 0. We got 19,285.7.15 Newton minus AB sine 72, because AB is also pointing upward direction, and the slightly 72 degree. So we got AB equals to negative 20,278.2 Newton. Because it's negative, it is a compression. Now we can calculate the Fx. Negative 200, negative 20,278.2 cos 72 plus AC. We got AC equals to 6,266.308 Newton, and it's positive, and we got it. AC is tension. At joint B, we just now we got AB and AC. At joint B, we already have AB. So AB equals to 2,000 20,278.2 sine 72 minus BC. Now BC we got 20,278.2 Newton. BC is the tension, and we need to find BD using Fx equals to 0. We got BD equals to negative 12,532.617 Newton. It's negative, it's compression. We already have AC and BC. Now we can find CD and CE using the Fx and Fy equal to 0. We got CD equals to negative 20,278.2 compression, and CE 18,798.925 tension. Now at joint D, we already have BD and CD. We can find DE and DF. So DE equals to 20,278.2 Newton tension, and DF 12,532.617 Newton tension. Join E, you can find EF and EG because we already have DE and CE. EF equals to negative 433 Newton compression because it's negative. And EG we have 24,932.428 Newton. It's in tension. And join F, we got FG equals to 433 Newton tension, and FH we got 12,532.617 Newton in tension also. At joint G, we can find GH and GI negative 433 Newton in compression, GH, and GI equals to 24,931.428 Newton in tension. And in joint H, we can find HI 433 Newton in tension, and HG 12,532.617 Newton in tension. Point I, we can find IJ and IK to IJ 20,592.244 Newton, and IK 18,700.643 Newton. Both are in tension. And joint J, negative JK, negative 20,592.244 Newton, negative, it's equals to compression, and JL 12,532.617 in tension. KL, at joint K, we can find KL and KM. KM equals to negative 20,592.244 Newton, negative, so in compression, Km equals to 18,700.643 Newton in tension. And join L, we can find LM and LN 20,592.244 Newton tension, LN 12,532.617 Newton in tension. Join M, we can find MN and MO 205.96.244 tension, and MO is 18,700.643 Newton in tension. Join N, because we already have LN, so we LN and MN, we just need to find NO. So NO equals to negative 20,592.244 Newton in compression. And the last joint is joint O, and we already have NO, we just need to find MO. We already have MO, NO, and we need to find MO. So using Fx equal to 0, we got MO 6,364 and 589 Newton point in tension. So that is all from me. Thank you.
Okay, so for our frame structure, we use a folding chair as the structure. And this is the picture of our folding chair. And this is our assumption for the folding chair. There is 5 points here. We can see A, B, C, D, and E. And we design the distance for every point, and we assume half the weight of a 75 kg person is supported by the side of the chair frame, and the folding chair is resting on the smooth floor so that we can neglect any horizontal friction force at A and B. And then we will find the X and Y component of all force acting on each point. Okay, so this is the free body diagram of the chair. We can see there is wave point downward here on the seat of the chair, and on the both bottom we have component BY and component AY point upward. And this is the component of the chair. We have here CY and CX, and EX and EY, and on this component we have EY, EX, and DY, DX. And for the seat component we have weight here and DY, DX, and here we have CY. Okay, so to find the reaction and external load on the chair, first step is we're gonna find the value of weight. As we know, the weight is half, acting on the seat is half, so we're gonna use half of the weight and multiply by 9.81, and we will get the weight equal to 367.9 Newton. And then we want to find the BY component, and to do this we use moment at A. Then we use the weight multiplied by the distance 0.36 and minus by by multiplied by 0.6, and then we will get dy equal to 220.7 Newton. And then we want to find the ay. To do that we use total Fy. Then we will get ay equal to 147.2 Newton. Okay, then now we want to find the force acting on this component. We have, okay, so first we want to find Cy. To find this we can use moment at T. So we will input the value of weight multiplied by the distance 0.26 minus by Cy and the distance multiplied by 0.2, and we will get Cy equal to 478.3 Newton. And then after we get Cy, we can find dy by using total Fy, and then we will get dy equal to 110.4 Newton. Okay, for this component, first we will find Ey. To find this, we will use total Fy on this component, and then we will input Ey minus 220.7 minus 47.3 Newton, and then we will get dy equal to 257.6 Newton. And then we can find Ex. To find this, we can use moment at C. Then we will input 220.7 multiplied by the distance 0.2, and then minus ey. Ey is 257.6 multiplied by 0.1, the distance, and then minus Ex multiplied by 0.25, and then we will get Ex equal to 73.5 Newton. After we get Ex, we can find Cx. To do that, we are just using total Fs, and we get Cx equal to 73.5 Newton. And on the last component, we already have the other force except dx, so we can find dx by using fx, total fx. and then we will get Gx equal to 73.5 Newton. Okay, that's all for the force acting on this chair. Okay, for the conclusion, thus we conclude that the frame members of the folding chair are rigidly connected and can support all load types. So the joints of frame could transfer moments also in addition to the axial loads. And by drawing the free body diagram and split the frame of the chair into separate members, we can find the reaction and external force on each joint of the chair using equilibrium. That's all.
Hello and Assalamualaikum. My name is Ahmad AMIRUN AKIF bin Ahmad JASRUL. My matrix number is 207449. So today I will be presenting the machines and analysis. And calculation. Without wasting our time, let's jump into it. So firstly, this is the picture of the machine we use, and the location of the pliers is just at my house. We may not provide the real-life structure with the loads, but in the next slide, we assume and create the whole structure. So let's go to the next slide. Reaction and external loads on the structure with free body diagram. In this section, we will assuming that the pliers are used to grip the nut at point B. A force of 30 Newton is enough for the handles just to grip the nut, and we will show step by step the force and moment at point C. Reactions at each point will be shown. After that, we also assume the jaws of the pliers exert only normal forces on the tube. So the diagram of the plier shows the information that we needed to solve the calculation. So let's look carefully to the diagram, as it will divide it into 3 points, which is point A, point B, and point C. Looking to the point A, there is a free body diagram of pin of A, and there are reactions towards it. Since we have a load we call is as FB, which determine the force exerted from loads to the pliers. The summation of Fx equals to 0, and we converted the angle force of FB into x-axis, which is FB cos 40 plus AX. Since we can directly find the unknowns, we need to continue our calculation. So summation of Fy is equals to FB sine 40 minus AY minus 30 Newton equals to 0. Still, we can find the unknowns. We can use the moment. The summation of moment of A is equals to FB times its distance to the point A, which is 0.035 meter minus 30 Newton, that times with 0.25 meter. Solve it all, and we can obtain unknowns. Therefore, FB is equal to 214.29 Newton. AX we get negative 164.16 Newton, and for the AY we get 107.74 Newton. So at point B, we're just calculating the force of the load which we have obtained before the previous slide. But in this free body diagram, we can calculate the FB in another way, which is summation of moment A equals to 0. So the original structure is here to help us more clear of what we calculate. So 30 Newton times 0.25 meter minus FB, which we have the value, times 0.035 meter equals to 0. And we get FB is the same as the value we get before. So you can use it as double check. Moving on to the last point, point C. So firstly, as usual, we need to write the summation of fx and fy equals to 0 because it is in static. So we use VC for the direction vertical and NC for the x-axis direction. Okay, so summation of fy equals to 0, negative VC plus FB equals to 0. And we get VC equals to the same value of FB. In x-axis, NC equals to 0 since there is no any reaction in NC. So we write equals to 0 because it is in static. And there is no other reaction against NC. So lastly, we calculate the moment of C and the summation is equal to 0 since the force at B is about to rotate anti-clockwise, so it is going to be negative. And MC minus FB times 0.025 equals to 0, and we get MC equals to 5.36 Newton turning clockwise. So lastly, the conclusion. To sum up the calculation, it is believed that it only requires to calculate one side of machine part as both of it will mirror the same forces exerted. This can be done by using equilibrium equation of forces and moment. Thus, we can find any value forces act on any type of machine we chose. We chose pliers as it is easier for us to find, and the calculation is quite simple, so that's why we chose pliers. Thank you. That's all from me.